Hi, today we're going to be looking at a 2015 PAT paper and doing question 5. Now question 5 asks us, for what values of m does the following have no real solutions? 4x squared plus 8x minus 8 equals m into 4x minus 3. Now when you see any question involving a quadratic and the question asks you when does it have no real solutions or one real solution or two distinct real solutions, your immediate thought should be the discriminant. Now let's recall, for a quadratic equation, ax squared plus bx plus c, a discriminant, which we'll denote by this triangle delta, is b squared minus 4 times a times c. And remember, if the discriminant is strictly less than 0, this means the quadratic has no real solutions. So what that means is, if we have an arbitrary quadratic with its discriminant less than 0, it means it was something like this. Or like this, or to be honest with you, any parabola-shaped curve that does not intersect the x-axis, which means that there are going to be no real values of x for which this equation is 0. And as this question asks us, for what values of m does it have no real solutions, we're going to be concerned with the discriminant being less than 0. So, let's begin. Now, the first step would be to get this in the form of ax squared plus bx plus c equals 0. Because then we can think about looking at the quadratic and looking to solve it, and then thinking about the values of the discriminant. So I would start by bringing this m term over to the left-hand side. So we get 4x squared plus 8x minus 8. M times 4x gives you 4mx, so subtracting it gives you 4mx. 3m minus 3m added across gives you plus 3m equals 0. Now let's collect like terms. So there's no other x squared term, so it's 4x squared. And we notice we have an 8x and a 4mx. So there's a 4 in both, so we can bring that 4 out. So we get plus 4x into, well that's going to be a 2 from here, and a minus m from here. And then we're going to get plus 3m minus 8 equals 0. Now, let's label this. So we have this is our A, this is our B, and this is our C. So we can substitute that straight into our discriminant formula. So we get that delta equals B squared minus 4AC, which equals 16 from the 4 squared into 2 minus m squared minus 4 times 4 into 3m minus 8. So let's simplify this. So from our term here, we get m squared minus 2m minus 2m minus 4m plus 4. So we're going to get 16 into m squared minus 4m plus 4. Simplifying here, we're going to get a 16 into 3m minus 8, and we want that to be strictly less than 0. So we notice that we have a 16 on the outside of both these bracketed terms, and as it's a positive value, it's not going to affect our inequality sign. So we can simply divide through by our 16 to leave us with m squared minus 4m plus 4 minus 3m plus 8 is less than 0, or m squared minus 7m plus 12 is less than 0. So now we notice that we actually have a quadratic in terms of m that we want to solve for the values of m for which this is strictly less than 0. So the way to go about doing this would be, let's sketch the curve of m squared minus 7m plus 12. So let's let y equal that and sketch a y versus m curve here. So where's that going to be 0? So you want m squared minus 7m plus 12 equals 0. So we can spot that this factors into m minus 4, m minus 3 equals 0. So we know for the values of 3 and 4, this is going to be 0. So using our quadratic sketch, we're going to have looking something along the lines of this, with that point being 3 and that point being 4. So we want, when this curve is less than 0. And we see that corresponds to this region here. So we can simply read off from the graph that our values of m for which this will hold is when m is strictly less than 4 and strictly greater than 3. And that's the answer to the question.